Hello, everyone. Good afternoon. This is Samiksha from Green Building Consulting and Engineering firm. And welcome to this expert talk of GBCE. And thank you for joining this session on LEED version 5 for Southeast Asia. This session is a part of GBCE's expert talks, and GBC is a green building consulting and sustainability consulting firm based in Bangkok and works across Southeast Asian projects and European projects as well. For next 1 hour or 90 minutes, we will explore what has changed in LEED version 5 and how these changes impact projects across Southeast Asia, and what project teams can do today to prepare for this transition. If whether you are an architect, or engineer, or developer, maybe sustainability consultant, LEED version 5 is a significant change that will influence the way projects designed, constructed, and operated. While previous versions focused heavily on efficiency parameters of energy, water, and materials, and their environmental performances. So LEED version 5, it expands its scope, and key elements or pillars we can see. These are decarbonization, quality of life, and ecology, conservation, and restoration. So throughout this session, we will discuss what these updates look like and how specifically they are applied for Southeast Asian projects, and will identify practical actions project teams should begin taking right now. So it's okay. Before we dive in, let me quickly walk through what we will cover today. So LEED version 5 is not just an credit update. It's much more than that. So it represents fundamental shift in how sustainability performance is measured and delivered across entire project lifecycle. And as you can see, we will start looking at the 3 pillars and the new philosophy of version 5, which is foundation of version 5. And because without understanding why these individual changes have been made, it's not worth it to move ahead. Then after that, we will do a side-by-side comparison of the 5 transformative shifts in the version 5. Then one of the most significant structural change is carbon, which is now mandatory, and we will walk through how it's embedded as a prerequisite and what the platinum embodied carbon bar means for the project ambition. So along with that, we'll have a look at energy decarbonization, the materials and supply chain, and then health and resilience. And since this session is focused on Southeast Asia, we'll spend dedicated time on what these global changes mean locally, the opportunities, the constraints, and the context that make this region unique. So then before we start exploring the details, I would like to understand who is joining us today. So just check on the notification you have got for poll and just vote for that. Okay, so we have four votes right now. Let's wait for few more. Yeah, so we have architects in the session, we have sustainability consultants, then we have students as well. Great. So till a few votes we have for this poll, we will launch another poll, which is for familiarity with LEED version 5. So you can vote for that as well. In the meantime, so you just have to vote on how familiar you are with LEED version 5. So maybe you are part of project. Maybe you just have heard about it. So yes, we have 4 votes. Great. So we have people who have who are aware of LEED version 5 but have not studied it. So that's a good start for them. Then we have people who have heard about version 5 for the first time. So it's a great start for them as well. And we have nobody who is already working on version 5. So yeah, we'll together work on that. So I think thank you for your responses. And I guess we can move ahead with the session now. Now that we know who is in the room and how much familiar we are, we'll just move on to the most important foundation, which is the foundation of LEED version 5. So this slide will explain why V5 feels so different from previous versions. So for the first time, every single credit in LEED maps back to the one of the 3 central pillars you see over here. So first is decarbonization, second is quality of life, and third is ecological conservation. So decarbonization is most structurally significant change in version 5. So carbon is now tracked across entire building life cycle, right from concept and construction through the operation and eventual demolition as well. So that means both operational carbon and the energy a building consumes day to day, embodied carbon, the emissions locked into the materials themselves are in for version 5. And critically, electrification is now a requirement for platinum certification. So you cannot achieve highest tier of LEED by running on fossil fuels, no matter how efficient the building is. Then the second pillar shifts the lens from building to people inside it, which is quality of life. So version 5 asks whether a building genuinely improves health, comfort, it provides resilience and inclusion for every occupant, not just average user by every occupant. Yeah, this is a more ambitious standard than indoor air quality checklist. So it encompasses thermal comfort, accessibility, mental well-being of the occupants, and how the building performs when conditions get difficult during a heat wave or a flood event or a power disruption. So ability of building to withstand with these hazards is also included in this pillar. Then the third pillar is the most forward-looking, which is ecological conservation. So LEED version 5 moves beyond familiar to do less harm. So doing less harm is not enough now. So approach is to ask teams to actively protect and restore natural systems, biodiversity, habitat, water cycles, and soil health are all in scope. So for projects in Southeast Asia, where development pressure on natural ecosystems is significant, this pillar will require genuinely new thinking at the site and neighborhood scale. So with this framework in mind, let's now look at how these 3 pillars translate into 5 big shifts that distinguish version 5 from version 4 and 4.1 in practice. So version 5 is not an incremental update. It represents a fundamental rethinking of what sustainable building means. So specifically for project teams operating in Southeast Asia, We just have walked through these 5 shifts that make this version structurally different from version 4. So resilience planning first. So for the very first time, resilience is baked in before a single decision is made. So uh, you have to do the resilience assessment before your design decisions are made. So V5 introduces 3 new mandatory prerequisites, which are related to climate resilience, human impact, and carbon assessment that must be completed at the project's outset. This shifts the profession from design first and certify later to understand risk first, then design. So in Southeast Asia, where projects face flooding and heat stress, so here this resilience planning first approach will be a game changer. Then carbon is mandatory in version 4. So in version 4.1, carbon was optional. In version 5, both operational and embodied carbon are prerequisites. You cannot certify without addressing them. Additionally, platinum certification now requires 20% reduction in embodied carbon. So this signals that LEED is aligning with global net zero commitments and that materials choices carry certification levels consequences as well. Then we have energy beyond energy use intensity. So EUI is no longer sufficient. So version 5 replaces efficiency only thinking with credits for electrification, grid interactivity, and peak thermal load management. The goal is to reward buildings that are smart grid participants, not just energy misers. So this is especially relevant as Southeast Asian grids decarbonize and demand response programs grow. Then we have materials in supply chain. So version 4.1 had separate credits for material certificates like environmental product declarations, ingredient disclosures, and responsible sourcing. So version 5 consolidates these into a single unified multi-attribute product scoring system. This reduces documentation burden while pushing teams to think holistically about a material's full environmental and health profile, not just a one dimension at a time. So in version 5, they have made LCA as a mandatory one. Then the final shift, it expands LEED's human and ecological scope. So resilience spaces, occupant experience, accessibility, and biodiverse habitat are all woven together, and climate adaptation is now mandatory, no aspiration. This signals that a certified building must serve its occupants and its ecosystem, not just its energy meter. So together, these 5 shifts move LEED from a checklist performance threshold to a framework for resilient, low carbon, ecological responsible buildings. So for project teams in Southeast Asia, early adoption of version 5 thinking, even on version 4.1 projects, will be a strategic advantage for them. So now we'll go through the shift 1, and it's one that perhaps most directly reflects where the world is right now. The title says it all. We are no longer designing for an idealized, stable climate. We need to be ready with what climate change we are facing right now. And then also we should be ready with the future projections. So we are designing for the climate change we actually have. And the most extreme climate we know will be coming. So the 3-stage framework for climate resilience is you can see on the diagram that left shows the diagram on the left shows how version 5 structures climate resilience as a progression across 3 stages. First is climate resilience assessment, so which is now a prerequisite. So before schematic design, every project team must complete a mandatory risk assessment of hazards. So its foundation is everything else we built on. So that's why. Then the second stage is resilient spaces. That's a new credit in indoor environmental quality, wherein building must remain habitable without mechanical systems during extreme events such as flooding or storms. So power goes out and the cooling or mechanical system fails. Still, your occupants should survive there. So this is how buildings are no longer just energy or efficiency performance. Those are care. So those are caring or caring for the occupants. It has. So in Southeast Asia, where wet bulb temperatures are already at dangerous thresholds, this is not a theoretical scenario. So we need to build the spaces with a better building envelope products. And the third stage is enhanced resilient site design. So this is also a new credit, which requires integrated site tested against catastrophic climate scenarios using IPCC pathways. So the four hazard categories on the right you see, version 5 identifies four specific types that project teams must address. So that's extreme heat, then flooding, then we have typhoon and winds and water scarcity. So the highlighted note at the bottom is critical for this for all of us. So flooding, typhoons, and extreme heat are not future risks in Southeast Asia. They are present day operational realities. So projects in Ho Chi Minh City or Jakarta or Bangkok and coastal cities are already dealing with these conditions. So what version 5 does is make hazard assessment mandatory from inception rather than leaving it as an optional design consideration. So the climate resilience sets the stage. Now let's look into the second shift, how carbon has moved from optional aspiration to a mandatory foundation of the entire operating system. So this slide captures what is single most consequential structure change in version 5. That's a carbon, which is no longer optional. The headline says it plainly, carbon is no longer optional. And the three numbers at the top tell the story quickly. So 2 new carbon prerequisites, 20% embodied carbon reduction required for platinum, and 0 on-site combustion permitted for platinum certification. So 2 new prerequisites means carbon accounting is now a baseline requirement for LEED certification, not a credit you pursue if your client is ambitious, but a floor every project must clear. So that's a prerequisite. Then for platinum certification buildings, 20% of embodied carbon reduction is the demand of material choices, not just operational systems, deliver measurable carbon outcomes. This will change procurement conservations with contractors and suppliers. So 0 on-site combustion for platinum means no gas boilers, no gas-fired hot water systems, no combustion-based cooking in commercial kitchens. So this is where Southeast Asian projects have advantage, where this region specifically has cooling dominated mechanical systems and not for heating. So that's why. So the first new prerequisite, operational carbon projections, requires teams to forecast lifetime carbon from day one of the project and a 25-year decarbonization plan, which is now mandatory. So this is a significant. It means project team need to think not just about how the building performs at handover, but how it will perform as decarbonizes as energy cost shifts and as climate conditions change over the next quarter century. So LEED now has set the long-term targets as well when the buildings are actually operating. So for developers, this is also long-term asset value conservation. Next, prerequisite is quantify embodied carbon. The second, so a whole building life cycle assessment, it counts, producing a full global warming potential number for entire building. This is a step beyond version 4.1 required, which was EPDs for select products. Here the ask is complete embodied carbon accounting across all materials and construction phases. For many project teams in Southeast Asia, this will require new tool, new supply relationships, and new skills in the consultant team, which is, of course, life cycle assessment. Then we have new credit, which is electrification credit. So for platinum projects, the electrification credit requires elimination of all on-site combustion. This is the credit that drives the zero combustion prerequisite for platinum. Buildings must shift toward fully electric systems, which in Southeast Asia means the conservation about grid carbon intensity, renewable energy procurement, and on-site generation becomes central to the project strategy. Then we have reduce embodied carbon, which is also a new credit. So with a 10 to 20% of global warming potential reduction target, this credit consolidates version 4.1 LCA credit. And the low carbon materials pilot into a single clear framework. Teams that invest in low carbon credit, low carbon concrete, sustainable steel, and responsibly sourced timber will find this credit accessible, but it requires early engagement with structural engineers and contractors. So integrative process credit in the version 4 and 4.1 also demands now for structural engineers and contractors onboarded at the early stages. So this taken together, these four elements, two prerequisites, electrification requirement, and embodied carbon reduction, means that carbon is now into every phase of LEED version 5 project. It is now not a specialist work stream you hand off to the sustainability consultant. It is a design driver from day one, and that shapes structural systems, mechanical plans, material specifications, and long-term operational planning as well. So next, we will go deep into the electrification credits, which directly supports zero on-site combustion requirement, we just discussed for platinum. So what the credit is worth up to 5 points for new construction and 4 points for core and shell projects. It rewards buildings that eliminate fossil fuel systems and transition to fully electric operations. So fully electric operations are for platinum projects, and for the others, it needs to eliminate fossil fuel systems. So the plan should be in place for that. So now we will look into the Southeast Asian context of this. So first thing to note is that Southeast Asia has structural advantage that many other regions don't. Most buildings in tropical climates have no space heating obligation, which I mentioned earlier as well. Heating is simply not a significant load. This means one of the biggest barriers to electrification in the temperate climates, replacing gas heating systems, does not exist here. The electrification conservation in Southeast Asia is therefore narrower and more traceable, focused primarily on hot water and cooking systems only. So quick wins for this electrification there are two. So solar water heating with a heat pump is the first. It replaces gas or electric resistance hot water with a highly efficient electric alternative, and it's well-established technology in the region. So induction cooking is the second, increasingly cost competitive. operationally superior in many commercial kitchen applications, and now a certification lever as well. So together options 2 and 3 under this credit can deliver 2 points with a moderate effort and a low cost premium. For many projects, this is the most practical starting point. So you can think about it. Then, if a project is targeting platinum certification, the strategy is go fully electric from day one, pursue option 1 for the full 5 points, and plan MEP systems accordingly. The critical point here is that there are no partial paths to platinum on electrification. You either eliminate on-site combustion or you don't. So this means decision needs to be made at project inception, not retrofitted during design development when systems are already specified. So early MEP consultant engagement is also essential over here. Then for core and shell projects, maximum achievable points are 4 under option 1. And there is an important additional requirement, which is for tenant fit out electrification. And that must be addressed in lease agreements only. So this is a significant implication for developers as well. It means the building's electrification commitment cannot stop at the base build. It must be contractually extended to the tenants. Then next, what we have is the Southeast Asia Platinum certification. So for the projects in Southeast Asia, how we can go for Platinum certification. So again, it's a 5 points. We can go with option 1 for which don't have partial paths. So the recommended combination is heat pump for solar water heating plus induction cooking, which together deliver 2 points at a minimal cost premium. And then from the foundation of a fully electrified system strategy. So this is highest value, lowest risk path to electrification compliance for most commercial projects in the region. Then we'll move ahead with the quantify and assess embodied carbon prerequisite. So, and it is one of the 2 new carbon prerequisites we referenced earlier. So as a prerequisite, this is non-negotiable, as we know. Every project pursuing LEED version 5 certification must complete this regardless of certification tier. The process has 2 steps, and the diagram on the right illustrates exactly where the carbon hotspots typically sit in a building. So step 1 is quantify. So what we need to quantify is to calculate cradle to gate global warming potential. So that's a life cycle stages E1 through E3. So for all major materials, this is applicable. The methodology is straightforward. We need to quantify multiplied by global warming per unit, potential per unit, then sourced from EPD, like environmental product declarations. And then the tools recommended are, we can use one-click LCA, as well, and can check on Tally and other softwares as well. So 2 things are worth emphasizing here. First is must include all ancillary structures with LEED boundary, within the LEED boundary. So not just a primary structural frame. So secondary structures, fit out elements, and site works should be counted. Second is full global warming potential number for the whole building, not just for environmental product declarations for the selected products, which was earlier approach in version 4 and 4.1. So this sets a materially higher bar in the version 5. Then step 2 is to identify top 3 hotspots. So once the quantification is complete, the team must identify the 3 biggest embodied carbon contributors and describe project-specific strategies considered to reduce their impact. This is not a theoretical exercise. It requires genuine engagement with the numbers and documented response. So for core and shell projects, there is an additional obligation. Findings must be communicated to tenants, which again reinforces the theme of extending sustainability commitments beyond the base build. Then the highlighted note identifies the three typical embodied carbon hotspots for Southeast Asian projects, and the diagram illustrates them clearly. The concrete structure is the largest contributor. Reinforcing steel bar is also the one, and the aluminum curtain wall is the third major hotspot. So what this prerequisite does is force a quantified conservation about materials that previously happened informally or not at all. Like we were supposed to select few of them. So here it counts on every material we use to build. So when a structural engineer proposes a concrete mix design, the embodied carbon implication is now a project metric, tracked, documented, and reported. So that change in procurement is dynamic, and it creates a clear business case for engaging suppliers who can provide low carbon alternatives with verified EPD. So now we have discussed about embodied carbon. We'll look into the credit connected to it to reduce embodied carbon, which is worth up to 6 credit points, and building directly on materials prerequisite we just covered. So there are 3 options. First is pole building LCA, and that is a foundation of the highest value pathway up to 6 points. It requires comparing projects A1 to A3 global warming potential against baseline, with points scaled to percentage reduction achieved. This is option that directly drives platinum requirement as well, which is 20% reduction and earns 4 points. Then option 2 is EPD analysis, layers on top of option 1, worth 2 to 3 additional points. So it requires use of environmental product declarations for materials, moving from whole building averages to product-specific verified data. For the 3 Southeast Asia hotspot materials, we identified concrete, rebar, and aluminum. EPDs are increasingly available from regional manufacturers, making this option more accessible than it was earlier. Option 3 is track construction carbon. So it is the most advanced pathway, which will add a couple of points by tracking contractor fuel and utility consumption during the construction phase itself. So this extends the carbon accounting beyond materials into the construction process. Site machinery, temporary power, concrete trucks will have this carbon emissions on site. So for teams with stronger contractor relationships and data sharing agreements, this is an achievable addition. So for points by global warming potential reduction, the table on the right makes the scoring logic transparent and worth understanding clearly. Meeting baseline is essential industry average performance and returns 2 points. A 10% reduction earns 3 points. The highlighted row in the critical one, it's a 20% global warming potential reduction, and it's a threshold for platinum certification projects, which will earn 4 points. So team willing to push further, 30% reduction earns 5 points, and 40 or more earns full 6 points. So this sliding scale is intentional. It rewards ambition proportionally and give project team a clear target to design toward rather than a binary pass or fail. So the key message here is platinum level embodied carbon performance is not a specialist or experimental undertaking for Southeast Asian projects. It is achievable with mainstream materials and procurement practices, provided the decision is made early and the structural engineer and contractor are engaged from the outside stage. So We are at the halfway point now, and a good moment to pause and connect today's content to your own project's reality. So let me ask you a question again, and you need to vote for that. So question is, are you currently involved in any project that could pursue LEED version 5? I have the votes. Okay. We have one which says not at the moment. Okay, another says yes, but LEED doesn't, LEED has not been discussed yet. We have two more in the not at the moment. Okay. Okay. Okay, so we have majority people who are not part of the project yet. So that's fine. And today is about building the knowledge so that when the opportunity arrives, we are ready. We are ready to advise. Okay. So let's keep going, and we'll now look into what's driving LEED adoption in this region and what that means for how we position Vision 5 to the clients. Next is energy from efficiency to decarbonization. So this is an important information because it explains one of the biggest mindset shifts in LEED version 5. So the audience may already be familiar with energy efficiency as we are, but LEED version 5 asks about how we reduce the carbon emissions, not the energy consumption. So it's related already, like energy consumption reduction is the first step that everybody is doing for the ongoing projects, but then next step version 5 asks is how we can reduce carbon emissions from that energy consumption. So we have the in LEED version 4.1 primary focus was energy consumption, as I said, and then project team typically concentrated on improving energy efficiency, energy use intensity through efficient HVAC systems, efficient building envelope, efficient lighting, and its controls, renewable energy certificates, or on-site installation of renewable energy. So LEED version 5 takes much broader approach. Electrification is the major shift. LEED version 5 encourages projects to eliminate or significantly reduce on-site fossil fuels combustion wherever feasible. So traditionally, many buildings in Southeast Asia have relied on gas-fired systems for water heating, kitchens, or other applications. So as we discussed earlier as well, we can have those systems as an electric alternatives. The second shift is grid interactivity. So buildings are no longer viewed as a passive consumer of electricity. So instead, version 5 recognizes that buildings can actively support grid stability by managing demand, shifting loads during peak hours, integrating renewable energy, and responding to changing grid conditions. So this becomes increasingly important as countries expand renewable energy generation. The third shift is introduction of new focus on reducing peak thermal loads. Rather than only improving equipment efficiency, LEED version 5 encourages project teams to reduce the actual cooling demand of building. This means greater attention to building orientation, shading strategies, glazing performance, insulation, and overall envelope design. So in many cases, the cheapest and most effective energy strategy is reducing the load before selecting mechanical equipment. So from Southeast Asian perspective, The changes are particularly relevant. Many electrical grids also across the region are still heavily dependent on fossil fuels, and cooling typically represents a significant portion of building energy consumption. As a result, reducing cooling demand through passive design and high performance envelopes can have an immediate impact on both energy use and carbon emissions. In fact, for many projects in this region, an envelope first design approach may provide greater benefits than simply installing more efficient equipment. So, uh, next is electrification, the shift in thinking. So, in version 4.1, energy strategy was built around three pillars: minimize energy use intensity, use renewable energy certificates to offset grid emissions, and optionally pursue grid harmonization. So the word optional is doing a lot of work here. Electrification is in version 4.1 was a choice. The credit you could pursue if your client was ambitious, or skip if the budget was right. But in version 5, framing is completely different. The directive is electrify, eliminate all on-site combustion, and for platinum new fossil fuel site. So three conservation pathways are, as we discussed, solar water heating through heat pump, gas to induction cooking, HVAC heat pump systems. So the shift in thinking this slide describes is really a shift from efficiency optimization to systems transformation. The version 4.1 asks, how do we run this building better? Version 5 asks, what kind of building should this be? That's a fundamental different design brief, and it requires the electrification conservation to happen in the earliest design stages, not at the latter stage of NDP decision. The next is to reduce peak thermal loads, and it represents one of the most distinctly Southeast Asian opportunities in the version 5. The reason is simple: because of tropical region, tropical climate, cooling dominated peak demand is core energy challenge. So here, option 1 is infiltration and balanced ventilation, so which sets envelope and ventilation quality baseline. It requires air leakage at or below 0.13 CFM per square foot, and with ventilation and exhaust airflow balanced within 10%. Two things are worth noting here. First is low door testing is not yet standard practice on commercial projects across Southeast Asia. This will require contractors to be briefed and scheduled into the construction program. And second, it's strategically important. Option 1 is prerequisite for option 4. Getting the envelope tight is foundation that makes peak load reduction modeling critical. Second is ventilation energy recovery. So option 2 targets energy penalty of bringing outdoor air, always significant load in hot and humid climates. So the requirement is 70% enthalpy recovery, 75% sensible heat recovery ratio, and energy recovery ventilation is particularly valuable in Southeast Asian climates precisely because both heat and humidity must be managed. Then option 3 is thermal bridging. So it requires compliance with ASHRAE 90.1 2022.
I think our colleague is frozen. Just bear with us for a minute.
Hello?
Yes, we lost you for a bit.
Yeah. My internet connection was.
Sure.
Yeah. So I guess we are discussing thermal bridging, so which is option 3 and requires compliance with the ASHRAE 90.1 and the practical implication is that this applies universally across Southeast Asian climate zones. Addressing it requires early coordination between architects, facade engineers, and energy modelers as well. So you see, for budget 5, we need all stakeholders on board before we design and decide to move ahead with the project. Then we have option 4, which is peak thermal load reduction. So option 4 is the highest value option in this credit, which is worth up to 3 points, and the one that most directly rewards good passive and active design. So it requires demonstrating a measurable reduction in peak heating and cooling load versus baseline with the 3 calculation pathways available. So what this credit does systematically is shift the energy conservation from annual averages, which were EUI measures, to peak performance. So which is actually stresses infrastructure and drives utility tariffs. In a region where grid reliability during extreme heat events is a growing concern, buildings that reduce peak demand are contributing to grid resilience as well as their own efficiency. So peak load management is one dimension of the grid relationship we see in the version 5. Now we have grid interactive credit, and it introduces a concept that's genuinely new to LEED. Building is not just as an energy consumer, but as an active participant in electricity grid. So this credit is worth up to 2 points. And it has a baseline requirement that applies to all projects regardless of which options they pursue. So the baseline before we get into the options is all projects must do 3 things: evaluate grid interactive measures, install interval recording meters, and ensure equipment is capable of accepting an external signals. This last requirement, signal ready equipment, has procurement implications. So it means building systems, particularly HVAC and lighting controls, must be specified with the demand response capability from the outset. This is not a retrofit friendly requirement. It needs to be in the equipment specification during design. So we have here 4 options. So very first is energy storage. So it rewards on-site electric or thermal storage with automatic load management. The operating logic is straightforward. Store energy during off-peak. Option 2 is demand response. So which requires enrollment in minimum 1-year demand response contract with a local utility or grid operator. Then option 3 is auto demand site management. So option 3 requires building automation system plan to shed at least 10% of peak demand for at least 1 hour in response to a grid stress signal. This credit notes that BS path is flexible. There are multiple technical approaches to achieving the load share target. So for projects with BS infrastructure, this is relatively low cost point. Then we have option 4, which is power resilience, and is the most ambitious pathway because it is most directly relevant to Southeast Asia grid reality. It requires ability from the grid and power all critical loads via on-site renewable and storage for a minimum of 3 continuous days. This goes well beyond a standard backup generator specification. It requires sufficient solar generation capacity, battery storage, and dimension for 72 hours autonomy. So what grid interactive represents is recognition that buildings are infrastructure, not just consumers. In a decarbonizing grid with the increasing renewable penetration and growing climate divergent disruption. Buildings that can shift loads, store energy, and operate independently during outages are assets to the grid system and not just to their owners. Then next we have is details on energy storage thresholds and power resilience. So here, this credit distinguishes between two storage types. One is electric, another is thermal. So electric storage, typically battery systems, and the requirement is 0.2 kWh per kilowatt of peak demand for 1 point, and 0.4 kWh per kilowatt for 2 points. So to put this in practical terms, 1000 kilowatt peak demand building would need 200 kilowatt of battery capacity for 1 point. And similarly for 400 kilowatt for 2 points. So at current lithium-ion phosphate battery pricing, this is increasingly within reach for medium to large commercial projects. So another is thermal storage, which is chilled water tanks or maybe ice storages. So the threshold is 1 kilowatt per kilowatt of for 1 point, and 2 kilowatt per hour for 2 points. Thermal storage is often more cost effective per unit of stored energy than battery storage in large commercial buildings. So earlier we discussed for electric storage, which was from medium to large commercial projects, and thermal storages can be efficient for large commercial buildings, and it integrates naturally with chill water HVAC systems as well that are standard across Southeast Asia. But then we have option 4, which is power resilience, which is a 3-step process. The first is identify critical loads. Second is design for read, and then sustain for a minimum of 3 days. So it's worth noting that we discussed in the resilience section as well that all identified critical loads must be powered continuously for 72 hours without grid connection. So during any extreme events, grid outages in Southeast Asia, so typically option 4 earns certification point, but teams serving clients who genuinely need operational continuity during extreme weather events should design outage duration, not just certification. So difference is system sizing, not the fundamental design. So option 1 and 4 together create a building that is both a grid asset during normal operations and storing renewable energy responding to grid signals, and as a resilient island during disruption. So next is the shift 4, which is about supply chain awakening for materials. So for the first time in LEED's history, the materials category asks project teams to look not just at what products are made of, but the entire chain of decisions that brings a product to site. So there are 4 distinct components of this shift, and together they represent fundamental change in how procurement conservations happen to LEED projects. So first is quantify and assess embodied carbon. Another is reduce embodied carbon. Third is building product procurement. And fourth is building and material reuse. So if we see the supply chain awakening this slide describes is ultimately about extending accountability beyond the building boundary. Version 5 is asking project teams to take care about what happens in the cement plant in Johor, for example, raw steel mill in South Korea, or an aluminium smelter in Indonesia, because those upstream decisions determine the carbon and the health profile of building being certified. So that is genuinely new ask, and it will reshape procurement relationships over upcoming years. So we'll get into the details of every point we discussed. So the slides get into practical mechanics of embodied carbon prerequisite. What materials must be included, which tools to use, and crucially, where to focus your reduction efforts first. So minimum materials and all must be included. The scope is cradle to grave, aligns with life cycle stages E1 through E3, and covering raw material extractions, transport to manufacturer, and manufacturing. So the 8 material categories that must included are shown at the bottom of the slide. The concrete, structural steel, masonry, asphalt, insulation, aluminium, structural wood, cladding, plus glass. So these represent major material volumes on typical commercial building and collectively account for the vast majority embodied carbon. So, the practical message here is embodied carbon measurement is not as complex as it might initially appear, and the reduction opportunities for Southeast Asian projects are accessible, proven, and in many cases cost neutral. The barrier is not technical, it's a process. Getting the structural engineer, the facade consultant, and the contractor aligned on low carbon specifications early in the design program is what determines whether the 20% platinum target is achievable. So the next is we have reduce embodied carbon credit, and it shows how the 3 options stack together to deliver up to 6 points. So option 1 is whole building LCA, another is EPD analysis, and third is track construction carbon. So option 1 is the foundation and the highest value pathway. It requires full A1 through A3 global warming potential comparison against same system baseline, meaning the project's actual material specification is compared against reference building using industry average materials. So points scale with the percentage reduction achieved from 1 point at the baseline performance up to 5 to 6 points at 40% or above reduction. So 2 things are critical here. First is the only path to 5 to 6 points. Option 2 and 3 cannot substitute for at the top of the scale. Second, it is required technical foundation for platinum. So without option 1 demonstrating 20% reduction in global warming potential, platinum is not achievable. So option 2 is EPD analysis. Option 2 operates on 2 parts. So path 1 requires project's average EPD data per material category, essentially demonstrating that products specified perform better than category average of global warming potential. And path 2 requires EPDs for 3 or more material types. So first, global EPDs are accepted. Teams don't need to wait for regional manufacturers to publish local data. Second, 3 Southeast Asia hotspot materials, concrete, rebar, and aluminium, all have reasonably good EPD coverage intentionally, so making compliance achievable within existing data. So for teams new to embodied carbon documentation, option 2 is where to start building confidence and process before tackling the full option of LC. Option 3 is to track construction carbon. Option 3 extends the carbon accounting boundary beyond materials into construction phase itself. So tracking fuel and utility consumption for job site operations. This is often overlooked, yet it represents some of the easiest 1 to 2 points in the grid. So key setup is timing. Construction carbon tracking must be established in tender documents from day 1, requiring contractors to report fuel consumption, generator usage, and temporary power from start of construction. So retrofitting this requirement mid-construction is difficult and unreliable. Projects where the main contractor is engaged early and the data sharing protocols can be agreed upfront. Option 3 is a low effort, high value addition to the grid strategy. So the reduced embodied carbon is a baseline we can see over here as well. So option 1 is the only path for 5 to 6 points, and the only way to demonstrate specific percentage global warming potential required for platinum. So both baselines and proposed may use design or as constructed quantities, maximum up to 10% variance allowed. The key material reductions you see over here for Southeast Asia is concrete, rebar, and aluminum. So in the threshold as well. Next, we have is building and material reuse. So the calculation methodology over here shown at the bottom of the slide is straightforward. Percentage global warming potential reduction equals baseline minus proposed divided by baseline multiplied by 100. So it's a simple formula. So the baseline represents same building design with the industry average materials, same geometry, same program, same structural system, but using standard market average global warming potential values for each material category. The proposed model uses actual specified materials with their verified EPD data. So the three material substitutions on the left are the of embodied carbon reduction for Southeast Asian projects, and the percentage reduction shown are based on verified regional data. So here in option 1, so building reuse up to 1 to 5 points. So maintain existing structure, floor decking, roof decking, and enclosure. So calculate 20% existing structure, 20% reduction in existing structure rating. So this is very much similar to version 4. Then 35% retained for 2 points and 55% retained for core and shell for 3 points, and for core and shell 10% retention gives him 1% scale. So retaining existing structure avoids manufacturing new concrete rebar entirely, and typically the single largest embodied carbon reduction to on retrofit projects. Now we have this building product selection multi-attribute scoring, and it represents most significant structural change in material category, where we 4.1 had separate parallel credits for EPDs, ingredient transparency, responsible sourcing, and multi-attribute evaluation. Version 5 consolidates everything into a single unified scoring framework built around 5 sustainability criteria. The diagram at the center of the slide illustrates exactly how this works. So the 5 sustainability criteria, every product is evaluated against 5 dimensions simultaneously, and this is the key innovation. So no single credential dominates. The system rewards products that perform well across multiple attributes. So embodied carbon, climate health via embodied carbon, EPD data, and energy used in manufacturing. This is the carbon dimension and connects directly to LCA work we have just covered. Then we have human health. So low VOC content and toxin-free formulation. This connects to indoor air quality and occupant health and is verified through certifications like declared red list free or health product declarations. Then we have ecosystem health, biodiversity impact, and responsible sourcing. FSC certification for timber, responsible mining standards for materials, and supply chain ability all fall under this criteria. Then we have social health. So fair trade certification and labor conditions in the supply chain. This is the most novel addition. LEED has not previously asked project teams to evaluate the social conditions under which building are produced. Then we have circular economy, which recycle content and recyclability at the end of life. This rewards projects designed for material recovery and supports the broader circularity agenda in the materials. So we have 3 scoring levels. Products are scored at one of the 3 levels with a multiplier applied to the reflect of depth of verification. So first step is basic EPD, FSC certification for timber or wood-based products, and single issue eco label. The level 2 is leadership, where third-party verified EPDs are there, and products from declared grade list free are also there. And then we have level 3, which is elite, which includes cradle to cradle approach and living building challenge approach. So over here, start with climate health. It adds human health as well. It layers circular economy, and in this and a product with an EPD but unknown ingredient content, poor recyclability, and opaque supply chain conditions is no longer able to maximize certification value as it did in version 4. So the system asks, is this product genuinely sustainable across all the dimensions that matter? Like like we see for climate, for human health, for circular economy, everything. And then, is this better? And then it will gradually reshape what manufacturers invest in and what procurement teams ask for. Next, we have shift 5th of version 5, which is aligned with the quality of life pillar of version 5. So human impact assessment. This first and most structurally significant change in human impact assessment, which is mandatory pre-design assessment covering 4 dimensions: air quality, noise, daylight, and thermal well-being. Critical word here is before. So this assessment must be completed before schematic design begins. This mirrors exactly logic of climate resilience assessment we discussed earlier. So version 5 is consistent in its approach. Understand the human and environmental context first and then design. So for project teams, this means the brief development and site analysis phase now has a formal human health assessment deliverable. So it cannot be deferred for design development or treated as a post-design compliance exercise. Aligned with this prerequisite, we have occupant experience credit as well. So the second major structural change in indoor environmental quality. So which consolidates all indoor environmental quality credits into a single unified credit. So version 4.1, thermal comfort, daylight, views, acoustics, and lighting were separate credits with separate documentation required. In version 5, they are evaluated holistically under one framework. So 2 aspects of this consolidation are particularly relevant for Southeast Asia is, first, there is an adaptive pathway specifically for tropical climates. We recognizing that thermal comfort standards developed for temperate climates are not always appropriate for naturally ventilated or mixed mode buildings in the tropics. Second, unified approach rewards buildings that perform well across all IQ dimensions, not just those that optimize for 1 or 2. So we have air quality, which is a significant step from MERV 8 that was typical under version 4.1 for Southeast Asian buildings, where PM 2.5 from traffic, industrial emissions, and seasonal haze is a real occupant health concern. This is a meaningful threshold. So the prerequisite also requires documentation of PM 2.5, ozone, and local emission sources during the pre-design phase. Then we have thermal comfort. So thermal comfort provisions include 2 important adaptations. First is adaptive comfort models are accepted for naturally ventilated spaces, acknowledging that occupants in naturally ventilated buildings can tolerate a wider comfort range than those in mechanical conditioned spaces, particularly when they have control over their environment. Second, overcooling is explicitly addressed, which is a genuine and widespread problem in Southeast Asian commercial buildings, where air conditioning is routinely set far below comfortable temperatures, which in fact treats overcooling as a health and energy issues in the buildings. Then we have noise and acoustics. Requirements unify background noise limits, reverberation time criteria, and sound isolation standards into a single set of criteria. So for mixed-use developments, open plan offices, and hospitality projects, all common building types in Southeast Asia, Acoustic performance is increasingly a differentiating factor in tenant satisfaction and building quality perception. So having a unified standard simplifies the acoustic consultant's brief and makes compliance more straightforward. Then we have daylight and views. So requirements address grade control, view quality, and daylight access to occupied zones with the solar angles documented as a part of pre-design assessment. So for Southeast Asian projects where solar exposure is intense year-round, glare control is frequently in tension with view quality and daylight access. So version 5 asks teams to resolve that point through documented solar analysis at the pre-design stages. When facade orientation, shading strategy, and glazing specification can still be meaningfully influenced during that stage. So what collectively it describes is a shift from IQ as a compliance checklist to human health as a design driver. The mandatory pre-design assessment, the adaptive tropical pathway, and the unified occupant experience credit together create a framework where the health of the people inside building is evaluated with the same rigor as its energy performance. So for developers and clients, this is increasingly a market differentiator. So occupant health and comfort directly influences tenant retention, productivity, and building reputation as well. Now we have from assessment to design for human impact and occupant experience, as we discussed right now, that the diagram shows integrative process prerequisite 2 at the center with 4 assessment outputs radiating outward. So each one directly informing specific indoor environmental credit options. So this is the assess then design principle made explicit. The pre-design assessment is not documentation for its own sake. It is the input data that calibrates the design responses that earn each credit point. So air quality context is related to HVAC filtration, noise and acoustics is related to sound. Option 4, sound environment, daylight and thermal context is option 3 and 5. And the adaptable option 2 is for 1 point where credit response to tropical climate context established in prerequisite 2 of integrated process. So for naturally ventilated or mixed mode buildings, which are increasingly viable in Southeast Asia, given the climate and the desire to reduce mechanical and cooling dependence. So the adaptive comfort model provides a more appropriate thermal comfort standard than the static ASHRAE 55. Then we have credit IQ credit 2 as a sound and lighting. So options 3 through 5 cover thermal comfort, sound environment, and lighting quality. These are the credit pathways that the acoustic, daylight, and thermal assessment from integrative process credit prerequisite 2 directly enables. Having completed pre-design assessment, the design team has site-specific data needed to set meaningful performance targets for each of these dimensions, rather than applying generic standards without understanding the specific conditions the building will face. Then we have biophilic. So option 1 is for 1 to 4 points. So biophilic option is worth putting separately because it represents a genuinely new direction in LEED's approach to occupant health. So biophilic design is the incorporation of natural elements, patterns, and connections to the living environment. It's supported by a growing body of evidence on its positive effects on stress reduction, cognitive performance, and overall well-being. So for Southeast Asian projects, tropical context actually creates natural opportunities for biophilic integration. The living walls, water features, indoor planting, and views to landscape are all climatically appropriate and culturally resonant design elements. Now we have this uh, now we have the important slide of today's session. So because everything we have covered so far has been framed in global terms, so this slide brings it home. These are 5 structural realities that define what LEED version 5 implementation actually looks like in Southeast Asia, and they're different in important ways from what project teams in other regions like of America or Europe will face. So first you see is high carbon grids. So in Malaysia, Vietnam, Indonesia, or all other countries of Southeast Asia, all have electricity grids that are around 60 to 80% operated on fossil fuel or are dependent on fossil fuel. So this has direct and significant implication for version 5 operational carbon calculations we discussed. So a building that is fully electrified but connected to high carbon grid is not a low carbon building in operational terms. So the carbon intensity of the electricity it consumes is high. The strategic response we can do is prioritize on-site solar and storage. So buildings that generate their own renewable electricity are partially decoupled from green carbon intensity. And as the battery costs continue to fall, the economics of the on-site generation with storage are increasingly compelling. So this also connects directly to grid interactive credit as well. So buildings with solar and storage that can shift load and shift load during outages are addressing both carbon and resilience challenge simultaneously. Then we have tropical climate and cooling. So cooling accounts for about 40 to 60% of energy use in Southeast Asian commercial buildings, a proportion that is essentially unmatched anywhere else in the world. So this means that energy performance strategy in this region is fundamentally a cooling strategy. So two immediate priorities follow from this. So first is envelope first design. So optimizing orientation, shading, glazing performance, and the thermal mass to reduce the cooling load before any mechanical systems is sized. So every kilowatt of peak cooling load avoided through passive design is a kilowatt of mechanical plant that does not need to be installed, maintained, or powered. Second is HCFC phase out. So the refrigerants used in cooling systems across region are subject to accelerating phase out timelines under the Montreal Protocol. And version 5 refrigerant management requirement reflects this. So teams specifying cooling equipment now need to select low global warming potential refrigerant options. Then we have EPD data gaps as the reality check. So this is a real practical challenge for the embodied carbon prerequisites and credits we have discussed so far. The regional manufacturer EPD coverage for concrete, steel, aluminum, and other major building materials significantly thinner than other regions. So it is, but good thing is that global EPDs are still acceptable initially. So international products data can be used while the regional ecosystem is still developing. So the action items specific to this are map available local EPDs early in the project program, then engage structural engineers in the embodied carbon conversations at the concept stage, and recognize that building the regional EPD database is collectively industry responsibility. Consultants would begin requiring EPDs from local suppliers even on projects not pursuing LEED, are contributing to development of the data infrastructure that the whole market will eventually need. Then the fourth reality check we have is climate resilience. Now, this point cannot be overstated for all of us. Flooding, typhoons, and extreme heat are not projected future risks in Southeast Asia. They are active, present-day operational realities that project teams are already navigating. So the 2011 Bangkok floods, typhoon, and its successors, the increasingly severe wet seasons seasons across the region. So these are not scenarios from IPCC report. They are events that have already happened and will recur with a greater frequency and intensity. So version 5 requirement for climate risk assessment before schematic design is not an academic exercise in this context. It is a professional responsibility. So project teams that complete a thorough climate resilience assessment are delivering better buildings and managing their clients' long-term asset risks as well. So those that skip it are leaving their clients exposed. Then we have, last but not the least, market and team readiness. So so the current norm in Southeast Asia is for sustainability consultants to be engaged post schematics, often at the design development stage. At the major architectural and structural decisions have already been locked in within three new prerequisites: climate resilience, human impact assessment, and embodied carbon quantification all require consultant engagement at the concept stage before schematic design begins. So this is a fundamental change to the project workflow and the consultant engagement model. So it means that for version 5 projects, the sustainability brief needs to be established one day. Sustainability consultant needs to be appointed with the architect and structural engineer, and version 5 goals need to be embedded in the project's brief from outset for developers and project managers in the room. This is single most important process change version 5 requires, and it starts with how you structure your professional appointments. So now I think it's an ideal moment to launch goal 4 for market perception. So I would like to ask what drives LEED certification decisions in Southeast Asia. So we have one as a corporate ESG, another as a tenant demand. That we have is regulatory or government requirements. Again, ESG and sustainability commitments. So we see LEED certification or green building certification is more of no more a prestige or market differentiation. It's a tenant demand, which is asset value we are looking for sustainability commitments we have, the clients have, and the government. So we see these are aligned with what climate change we are facing to, and where we are heading towards. So I guess we'll move ahead with this, where we can see that for version 5, what changes are roles. So for developers and clients, version 5 requires 3 things. First is to commit version 5 before design brief is written. So we need to decide on like the 3 new prerequisites. We need to incorporate those into the very first basic design stage. Then second is fund the 3 upfront assessments: climate resilience, human impact, and embodied carbon. And the third is recognize that carbon plan is a board level commitment. So a 25-year decarbonization plan is not a technical document for the sustainability consultant to manage. It's a long-term asset strategy. Then for architects, the most significant change is that integrated design process is mandatory, not a best practice recommendation, but a certification requirement. Then for MEP engineers, we have all electric HVAC systems are required for platinum, and the entire system specification must be planned from day one. So 4 specific technical requirements define new MEP baseline. All electric systems for platinum, grid integrative capability across major building systems, MOV 13 minimum filtration for air handling, and peak thermal load modeling as a standard deliverable. So the grid interactive requirement in particular means MEP engineers need to be specified building systems that can receive and respond to external grid signals, which has implications for control specifications in the DS architecture and equipment procurement. Then we have contractors and suppliers. So V5 creates 3 new accountability requirements that extend well beyond the construction contract. So EPDs are now required under multiple multi-attribute scoring systems. Then construction and demolition waste diversion tracking is required. Then the carbon tracking starts at procurement. So construction carbon credit requires fuel and utility data, as we see. Then we have operators and facility managers over here. So for building operators and facility managers, version 5 introduces most significant post-occupancy obligations in LEED history. So 3 specific requirements define new operational standard. 5-year energy reporting to LEED platform is mandatory. Then we have monitoring based commissioning for 3+ years, more than 3 years, ensures building systems are maintained at design performance levels and not allowed to deteriorate. So what the slides collectively describes is a project delivery model where sustainability is everyone's responsibility from the first client briefing meeting through the building's operational life decades later. So with that, we have now a 5th goal with the team readiness. So I would like to ask how prepared organization feel to deliver version 5. So if we can have votes for how would you rate your organization's current readiness to deliver version 5 project? Great. So we have 2 votes which mentions mostly ready and minor adjustments are needed. Then we have okay. So we have a team with, who are mostly ready, and I hope once we start working on version 5, so we'll be fully ready and we can start. So the next is before we move to the closing polls and Q&A, so I just want to brief what we have discussed so far. So 3 pillars, as we all now aware of, are decarbonization, quality of life, ecology, that every credit connects to one. The carbon is now mandatory. So 2 new prerequisites, platinum certification requirements for carbon, and the 0 on-site combustion. Then energy is equal to full decarbonization, and materials is no longer a specific or specific material selection. It's a design decision. It's a procurement decision. And last but not least is SCA demands early action. So for version 5 to be ready and to start with, we need to have all stakeholders onboarded right from the client meetings, right from the kickoffs of the project. So we have 6 now. So when will LEED version 5 become dominant standard in Southeast Asia? Maybe within 1 year, 2 to 3 years, or it may take 4 to 5. or much longer than that. Can we have some votes on the poll? Okay, so 2 to 3 years. Yeah. So we have 3 votes, which says within 2 to 3 years. So LEED GBCE has pushed the deadline of version 4 and 4.1 registrations to next year, June 30th, 2027. So let's hope it will be dominant standard in Southeast Asia for another couple of years. Yeah, so that brings us to the end of today's session. And I would take a moment to thank you all for your time, your engagement. And we have covered a lot of ground today for version 5, right from 3 pillars of version 5, transformative shifts, 5 shifts of the version 5, into a technical depth of carbon prerequisites, energy decarbonization, material supply chains transformation, occupants' health and resilience. So the central message is V5 is ambitious, but it's not unreachable. You see, pathways where we have discussed about low carbon materials, then the electrification, design, biophilic occupant experience are all commercially available, regionally appropriate, and increasingly cost competitive. So what version 5 demands most is not new technology. It demands earlier decisions, deeper collaboration with all the stakeholders, and a genuine commitment to outcome rather than compromise. So before we open for questions, I would like to have another 3 polls, which will ask about biggest concerns about transition to version 5, then what's needed for developer or owner to buy in version 5, and the confidence after today's session.